Good morning, everybody. So we are now in the third section on how to graph funky functions, I suppose, if you want to put it then. So for today, we're going to be looking at how to graph irrational functions, as in the last two sections, we talked about how to graph rational functions then. So here is an example of an irrational function where everything just looks completely nasty, and then we just don't even know really like how to start. But in a way, it is very similar to what we did in the past. And the thing about math also is that we always try to build on the previous part in order to make connections and also to be able to expand further. So here's an example of one where I want you to sketch y is equal to the square root of x times x minus 6 times x plus 3, all divided by x plus 3 times x minus 3. You'll note that, yes, inside you do have a rational function because you have a ratio of two functions that are polynomials in the numerator and in the denominator. But what makes it really nasty is that I want you to take the square root of it. So first, we'll just go through the same procedure as we did in the past, which is to simplify as much as possible. So you'll note that both the top and bottom, there is a x plus 3 and an x plus 3 that we can cancel out, and that will now give us a simplified equation as the following. And in the last section, we learned that whenever you have a factor that cancels on both top and bottom, that creates a removable discontinuity at that x value, which makes it equal to 0. And in order to figure out what that removable discontinuity, that point where there's a hole in the graph, we plug the value of x equals to -3 back into our equation that's simplified. And it turns out in this case, this is where it's a little funny because when we plug in -3 in here, you'll see that it's actually going to be undefined because you get -3 for x, you get -9, and then you get -6. So three negative numbers multiply to each other, all inside the square root. You can't take the square root of that. So as a result, that removal discontinuity technically isn't even there because the entire graph isn't there. And so this is something that we have to watch out for because now we consider what happens when the inside is negative because we can't take the square root of a negative number. So we'll still go through the same characteristics as we said. First, we'll solve for the removal discontinuity, which doesn't exist. Then we solve for the zeros of the graph, meaning where does it hit the x-axis. So that is looking at when x is equal to 0 and also x is equal to 6 because those are the factors in the numerator. Then we have the vertical asymptote. That's when the denominator is equal to 0. So that's at x equals to 3. And then the other thing that we added on is the end behavior, meaning what happens when x approaches towards infinity or negative infinity. And in this case, there is no finite number or real number that it's going to approach because you have x squared on the top and you have x on the bottom. So that means because of the theorem that we derived last time, the inside becomes x because it's x squared divided by x, and the square root of x doesn't really go anywhere numerically then. So the end behavior is non-existent, but I just wrote it out right here. Y is equal to the square root of x. That's basically, I guess, what it gets closer and closer to as x gets bigger and bigger. Okay, so those are all the characteristics that we looked at from last time. And here you can see the same chart that I built just like last time too. So I took each one of the factors in each and put it in each row. And then I also divided each row by the numerical values that we found in the zeros and the vertical asymptotes because that's where the signs are going to be changing. So 0, 3, and 6, that's because of the zeros and the vertical asymptotes. The factors right here are the ones that are up here, and I try to put them in kind of like nice little order so then that way you can see a nice little pattern over here. So again, if you don't remember how it works, is what we do is we take a value and we plug it in there for each of the factor to figure out if it's positive or negative. So for example, I am going to take a value that's less than 0 for this interval right here and then plug it into this factor, and then the result is that it's a negative. But whereas if I take any number between 0 and 3 and plug it into x, you're going to get something that's positive, and so on and so on and so on. Giving one more example, let's take a value between 3 and 6, so let's say 4 for example, and plug it into here. And when I plug 4 into this factor, 4 minus 3 is going to be equal to 1, which is a positive number, and that's where the plus comes from. So just like last time, I'm going to go ahead and build this chart. And then after I input the 3 factors and going to create the chart according to it, I am going to now write what y is equal to, or I'm sorry, the combination of all those factors put together when multiplied and divide. What do you get then? So that means that for this guy right here, the whole thing, because that's what the inside of the square root is equal to, that is going to be equal to negative because it's the result of 3 negative numbers multiplying and dividing by each other. Over here, that's positive because it's the result of a positive factor multiply and divide by 2 negative factors, and so forth. And this guy is going to be negative because you have 2 positive and negative, and this guy is going to be positive because everything here is positive. So in the past, we said, okay, well, we can now create a graph because we have what the equation is equal to, and we can kind of sketch out what it's equal, what it could become according to all of the characteristics above. But I am going to take it one step further because of the square root that we have that we didn't have before. Now, this is what's inside the square root. And if you remember what I said earlier, right, we have to consider taking the square root of that number to see what the numerical value is. And any time that your square root or what's inside your square root is negative, you actually can't take the square root of it as a result because you get something that's imaginary. So you can see how the next step, I said what y is equal to, because y is equal to the square root of everything that's in this thing right here. So I can't take the square root of a negative number. That's why you see DNE over here for it does not exist. Whereas over here, same thing, you have negative. So that means y is equal to does not exist. And everything else that is positive, we can actually take the square root of, which becomes a positive number. So in the end, we can kind of see what our domain of the graph is because y, what we're trying to graph, is going to be only between 0 and 3 inclusive, and also from 6 on. But whereas everything in between, you're not going to be able to yield a value of y for the range then. Okay, so as for the graph, now we go ahead and put everything in that we learned about in the characteristics, and also where is it positive and negative, and graph it out. We know that you have a 0 between 0, sorry, you have a 0, meaning where it crosses the x-intercept at x equals to 0 and x is equal to 6. And then afterwards, you have a vertical asymptote at 3, and then you also have an end behavior. And I can see that I made a mistake already because I wrote down 3 is going to be a 0. So we can go ahead and change that actually, just to kind of modify our answer. So as of right now, we said the 0 is located at 0 right here. So I'm going to go ahead and write 0. And we have a 0 at 6 over here. And 3 is supposed to be a vertical asymptote. So that means that this is actually going to be a vertical line like so. In terms of what the graph looks like now, after you have the zeros and the vertical asymptotes, well, that's where these guys comes in. Between 0 to 3, everything is positive. You're starting at 0, you have a vertical asymptote. So my graph actually doesn't end this way, but instead it's most likely going to go up like this then, going towards the vertical asymptote. Because again, everything has to be positive within this interval. So I do apologize for that part. Let me go ahead and get rid of that. Okay. For the next part, from 3 to 6, we don't have anything graphically because you can't take the square root of those numbers again inside the square root that are negative. So there's no x value that will work between 0 to 6 exclusive of those endpoints. And also there are no values that's less than 0 for x that will yield something also. So that means that's not part of the domain and that's not part of the domain. But whereas after x is equal to 6, you have y that are supposed to be negative, and you're going to start at x equals to 6, and you have y is equal to 0, so that's your 0 right there. And we said that for the end behavior, your graph is getting closer and closer to y is equal to square root of x. So I guess if you can kind of imagine it, here is kind of like a sketch of y is equal to square root of x, which is going to be a sideways parabolic curve. And the curve itself is going to get closer and closer to it then. Now, do you have to be that precise? And the answer is no, because again, this is just a sketch, but it's just nice to be able to translate these type of things. So then that way you have, a better analytical skill and something for you can sharpen. Okay. All right. Now, let's move on to the next question over here, where you have y squared is equal to x times x minus 6, all divided by x minus 3. You'll note that what I did for this problem, I kind of piggybacked onto the previous problem because it's kind of the same model over here, or same equation in a way, but instead of having the square root, we have squared, y squared is equal to that equation. So if you're wondering, okay, well, what's the difference? Because if I square both sides, technically we do have the same equation. It actually does make a difference because as I tell my students all the time, what is the difference between writing something like, say, y is equal to square root of 9 versus y squared is equal to 9. The difference is, in the first example, we see that y is equal to square root of 9. You only have one answer, which is equal to 3. But in the second equation right here, you have two answers because we have y is equal to plus or minus 3. So what that means is, yes, we still go through all the characteristics. Yes, we still go through all the graph. But when we get to the very, very last part, we're going to go ahead and change something a little bit differently. So you'll see that here we have y squared is equal to x times x minus 6, all divided by x minus 3, same as the column that's over here. As the row that's over here. So negative, positive, negative, positive. So negative, positive, negative, positive. That is what y squared is equal to according to my equation. Now I am going to go ahead and solve for y. So the first part, yes, that still does not exist because y squared can't equal to a negative number, nor can it be a negative number here. So that's why these guys are d and e. But the part that's different is that now we have y is equal to plus or minus instead of just a plus. Plus or minus instead of just a plus because of what we just said over here. So graphically, what that means is that you have y that will yield, you have graphs that will yield two portions of the graph because there's a y value that's positive here and a value that's going to be negative here. In terms of how that looks in the graph, this is basically what it looks like. And again, I have to change a modification because I kind of messed up earlier. And, that's my fault. I didn't check. So in the first graph, you can see that we have a graph that's getting closer and closer to y is equal to square root of x, as we said. Here, we drew kind of the same thing, but I drew it as a lower curve because what I want to do is, I guess I want to squeeze everything in, but it's basically supposed to be the same curve. Now, the difference, as I said earlier, is that we have two values of y that will yield, because of the solutions over here. We have the positive value and then we have the negative value. So what that means is, as a graph, I need to draw something that's symmetric to what's above the x-axis every single time, below whenever we have a positive and a negative. So here we have the upper part, here we have the negative part because of plus or minus. And over here, as we mentioned earlier, we have a vertical asymptote at x equals to 3. So let me go ahead and erase that actually, just to kind of make it a little bit prettier for those of you guys. So that way you don't have to see my mistake again. So as we said, vertical asymptote right here. Okay, and from the previous example, we said the graph would actually go up like this. So in this example, we still have that. We still have a graph that is going to curve, right? Concave up, that's what we call it, going upward like this. But now, in addition to that, we also have another portion that is going downward like this, and it's still going to be, this is concave down if I remember correctly. And it's going downward towards negative infinity because we have two parts of the graph that are symmetric. So that's just mimicking what we have over here. Okay. All right, so now let's look at our last example. Here we have x is equal to, sketch y squared is equal to this equation. And for some of you guys, you might be able to try this on your own actually, now that you've seen how this actually works out. So if you maybe want to take say a couple of minutes and try it on your own before you actually go on, pause the video, I would advise you to do so. Just go through the same characteristics as I did and see if you can get the graph. Okay, so assuming you did try that, or if you just wanted to take a look, let's see how it goes then. So first, as we said, we're going to simplify the equation. So factor everything. Nothing gets canceled out on both top and bottom. So that means there's no removable discontinuity. Okay. And by the way, keep in mind that anytime you do have a removable discontinuity, that is not going to be a factor that you actually put into your chart, because those two factors get canceled out. So you don't actually have to worry about plugging in to see any sign changes. So characteristics, no removable discontinuity, so we're good. The zeros are at 5 and -5 because of the numerator. The vertical asymptotes are at 2 and -2 because of the denominator. And also horizontal asymptote, now that was the one thing that we added on last time. And it's going to be equal to 1 or -1. And if you're wondering where does that all come from, well, let's go back to the equation over here. End behavior, again, is looking at when x is approaching towards a really large negative number or really large positive number. When we plug in x for a large value, this will yield x squared divided by x squared, because the -25 and the -4 are going to be so small that they're insignificant. As a result, for large values of x, we can kind of banish those guys, and that leaves you with x squared divided by x squared, which was equal to 1. Now, because it's y squared is equal to what's on the right-hand side, which is 1, that's where y is equal to plus or minus 1 comes in. So what that means graphically is that you would actually have two horizontal asymptotes, one at y is equal to 1 and y is equal to -1. And that's basically just a reflection of what we just said over here, because we have asymmetry about the x-axis. So create your graph just like what we did right here. And again, I just tried to align them nicely so that way we have a nice little pattern to go by. We solve for each plus or minus, we solve for each factor. Where is it equal to a positive? Where is it equal to negative? We solve for y squared, which is supposed to be all of these factors multiplied and divided by each other. And then afterward, we solve for y. So this is exactly the same idea as before. Okay, so you can see where is it does not exist, where is it does not exist, where is it supposed to be positive, negative, positive, negative, positive, negative, because we have, again, y squared is equal to the equation, not y is equal to the square root of the equation. So if everything is okay with you guys, I'm going to go ahead and turn the page over, show you what the graph looks like, and hopefully you guys got the same thing. So, this one's a pretty neat looking graph because we've never really seen something like it. So as we said, you have your horizontal asymptote at y is equal to 1. You also have your horizontal asymptote at y is equal to -1, because those are your end behaviors. Whatever you graph up here, you're supposed to graph down here also. So that's why the graph looks kind of funky like so. All right, so, stay safe, and I will see you guys next time then.